Alright, we are going to work on this guided practice. Before we get started, there is one more problem up here that is an example for us, and it talks about vacation. Leigh exchanged $50 American money, and she received $60 in Canadian. Use a ratio table to find out how many Canadian dollars she would receive for $20 in American. So they have set that upwards, and we showed $60 in Canadian, $50 in American money. Then over here, they put the $20 in American. Now they had to figure out how we're going to get from 50 to 20. So what they did was they divided by 10 and got 5. What you do on the bottom, you do on the top. And then they multiplied up times 4 to get to 20, and multiplied up times 4 and got 24. So for 20 American dollars, they will have 24 Canadian dollars. All right, if we move down to our guided practice, one thing that I want you to know is no matter what, if you do the same on the top and the bottom, you're okay. So this example tells us that Santiago receives an allowance of $7 every week. How much does he receive after 4 weeks? And they give us this 1 and week 4, and they gave us 2 boxes in between. So logically, if it's 1 blank blank 4, what would we put in there? We would just put in the weeks, right? Week 1, week 2, week 3, and week 4. All right, so hopefully, I'm going to move this over just a little bit because I feel like you can't really see the whole thing. There we go. All right, so if the number of weeks goes up every week by the same, so week 1, then we add 1 and get 2, we add 1 and get 3, we add 1 and get 4, logically we have to do the same on 7. So we have 7, we add 7 more, and we get what? 7 and 7 is 14, plus 7, 21, plus 7, 28. Now, I know I had preached you about doing the same on the top and the bottom, but it's doing the same value on the top and the bottom. So because we doubled this, plus 1, plus 1, plus 1, if we double on the top, as long as you're doing the same motion on the top and bottom, you're okay. So if you're going to keep adding this number on each time, if you keep adding that number on each time, it will still be equivalent. All right, so for 4 weeks, he would earn $28. All right, let's look at Tanya. Tanya runs 8 kilometers in 60 minutes. I'm going to go over the screens. I think I put on the next one. Yeah, that's higher. 8 kilometers in 60 minutes. So we're back at the top. At this rate, how long will it take her to run 2 kilometers? So now they gave us an 8, a blank space, and a 2. So how are we going to get from 8 to 2 in 2 steps? What can we divide 8 and 60 by? We got to go down because going up isn't going to really help us. So if we scaled down, what could we divide by both those numbers? I think we could divide by 2. If we divide by 2, divide by 2, divide by 2, we would get 4 and 30. So now, how are we going to get from 4 to 2? Divide by 2 again, divide by 2 again, and we get 15. Because there's 2 15s and 30, 2 2s and 4s. And so, for 2 kilometers, it would take her 15 minutes. All right, number 3 does not get us anything in our boxes. We have to figure this out. So, Lamika buys 12 packs of juice boxes that are on sale, and she pays a total of $48. So 12 packs, 12 costs her 48 bucks. Determine how much Lamika will pay to buy 8 more packs of juice boxes at the same store. So we need to put an 8 over here because that's the number of juice boxes, and now we have to figure out how in the world to get there. Well, if we use greatest common factor, we would see that 12 and 48 are, they're factors of each other, right? 12 can go into 48. So what if we divided by 12 on the top and the bottom? We would get 1. 12 divided by 12 is 1. And 48 divided by 12, how many 12s go to 48? And we get 4. So now, how do we get from 1 to 8? 1 times 8. What you do on the top, got to do on the bottom. So 4 times 8 is what? 32. So if we want to look at how much she will pay to buy 8 more packs of juice at the same store, she would pay $32 to buy 8 more packs. At the bottom it says, how can we determine if two ratios are equivalent? How do you think we can determine that? If they are simplified by the same ratio, then they are equivalent. If they can be simplified to the same ratio, for example, 1/3, 2/6, and 3/9 are all equivalent because they simplify to 1/3. So, if they can simplify to the same ratio, they are so we have what example they give us? They gave us 1/3, 2/6, and 3/9. 1/3, 2/6, 3/9 can all reduce to what? 1/3. All right, take a pause. I know I was in your way to write some of that. Take a pause. Make sure you have that down. If they can simplify or reduce, you know what? I feel like I should write simplify in here instead of reduce, because I feel like using two different words is just not a good idea. If they can all simplify to 1/3. Okay, if they can simplify to the same ratio, then they are equivalent. 1/3, 2/6, and 3/9 can all simplify to 1/3. That means that they are equivalent. And if you look back at your problems, the number 3, 8/32, if we divided it, if we multiplied it up or divided it down, they would all simplify down to 1/4 or 12/48 or 8/32. So all those are equivalent because they all simplify down. All right, from now you are going to go into your independent practice. If you have questions, please feel free to let me know. I want you to attempt to do this on your own, even though it's going to be difficult. We're going to do some more practice on this tomorrow. This is the hardest concept to get in ratios. So once you have this down, you're going to be good as gold. I hope you have a great day, and I hope you make great choices. All right, today we are going to be looking at scaling. If you do not have your Glencoe book out, make sure you have it out now. We are going to be on pages 41 and 42 today, looking at how to scale or multiply and divide two quantities by the same number to get scaled up or scaled down. Okay? Now, many times to get a ratio table filled in completely, we actually have to scale up and then scale down. This example that they give us here is done for us, and it talks about cans of corns that are on sale at 10 for $4. Find the cost of 15 cans. Now, why someone wouldn't just buy 20, I don't know. Or just 10, I don't know. But apparently this person wants 15. So, what they did was they put the ratio, the beginning ratio of 10 cans for $4 here, and what they wanted the end to be right here. So 15 over, we don't know. So that's why that is left blank. So we have to figure out how we're going to get from 10 to 15. Now, you can't do minus and add. We have to do multiply or divide. So, what we could do is either divide both those numbers or multiply both those numbers by the same thing. And as you see down below, they decided they were going to divide both those numbers by 2. So 10 divided by 2 was 5. 4 divided by 2 was 2. And then they said, well, how would I get from 5 to 15? Multiply by 3. What you do on the top, you got to do on the bottom. 2 times 3 is 6. So 15 cans would cost $6. Okay? We're going to be doing some practice at this. This is a really good example to get you started with. I'm going to move this down here a minute, and we're going to look at Joe here. And hopefully, let's see, maybe there we go. Okay. So this is down your page. I just had to move on because I didn't have enough room on my smartboard. Joe mows lawns during the summer vacation to earn money. He took 14 hours last week to mow 8 yards. At this rate, how many lawns will he mow in 49 hours? Sorry, I keep switching from yards to lawns, but I call them a yard and the book calls it. I call them yards, the book calls it a lawn, and I get confused still. All right. So first, they give us 14 hours, 8 lawns. And they want to know 49. So they show us again, is there a number by which you can multiply 14 to get 49? And if you look at your multiplication chart, you're going to find that the answer is no. Okay? So the answer here is no. So if we scale back, if we divide down 14 divided by 2, then we can multiply up times 7 and get to 49. So we are going to scale back by 7, scale back to 7, divide by 2, scale back to 7, scale forward to 49. So now Joe can mow 28 yards or lawns in 49 hours. So again, what I did on the top, we had to do on the bottom. 8 divided by 2 is 4, and then 4 times 7 is 28. Whatever you do on the top, you have to do on the bottom. I know I keep repeating that, but it's super important. If you don't do it that way, it's going to be wrong. You can't multiply 1 by 2 and then 1 by 3 or add and subtract in these problems. It just does not work out. All right, they gave us a got it problem. It's going to be a little tough, but I want you to try and figure this out. I'm going to give you a hint. You have to divide and then multiply. So think of a number that you can divide into both 25 and 10. And then you'll figure out what you have to multiply up to get to 105. Take a pause, try and figure it out, and come back in 5, 4, 3, 2, 1. All right, you should have paused and be back with an answer or what you think is the answer. If you got it wrong, hey, that's okay. We're going to practice this for a little bit until we get it right. If you want to divide by something on the top and bottom, best bet is divide by 5. Divide by 5. 25. How many 5s can go into 25? 5. So 25 divided by 5 is 5. How many 5s can go into 10? You should have said 2. And 10 divided by 5 is 2. Now we got to scale up. What are we going to multiply by 5 to get 105? Well, how many 5s are in 100? How about, let's see. Well, there's 25s in 100. So if we need 5 more than 100, we would be at 21. So we have to do times 21 down here. So 2 times 21 or 21 plus 21 is what? If you said 42, you got the right answer. So, how many, child's height measures 105 centimeters. Estimate her height in inches. What is her height in inches? It is 42 inches. Don't forget that label. All right. So, comparing centimeters to inches, this is a great way to do that. Sometimes those conversions can be really hard, but sometimes if you have a chart like this, a scaling back and scaling forward idea, it helps you to figure out those answers.